Hello friends, today I come with a new example on the Gauss elimination method. Okay, we have a question. This is a system of linear equation with three equations and three unknowns. Okay, the question says solve the system above using Gauss elimination method. And as we all know, when we are using Gauss elimination method, we are supposed to turn the whole equation to be in this form. I will write it aside at the side of the question and you'll see. Alright, this is how we are expected to turn the equation. These ones are our leading diagonal. That means from this question, the leading diagonal here is expected to be ones, and then these are our unknowns. Alright, let's go to the solution without wasting much time. Solution. The question I have above is what I put here. Alright, come with me. The 2 here, 4, 2 for x, 2, 4, 2, 3, 4, minus 3, 3, 4. I just put the whole of this question, the system, into a matrix form. And I call this matrix a coefficient matrix. Alright. So, allow me to name this as my row 1, this as my row 2, and this as my row 3. The whole of this as row 1, row 2, and then row 3. Okay, so I'm sorry for these mistakes here, but I will explain. Alright, so since I have all of my equation, the whole of this is what I repeated here. So what actions do I need to take on this matrix in order to be in this form? Okay, so since I'm using Gauss elimination method, I will look for a strategy to turn the whole of this matrix so that I want to eliminate this, and this to be zeros, and then I want to make this, and this to be ones. Alright, so the first thing I will do here is to say I will multiply row 1, that's the whole of this row, by 2, and then I will subtract row 2 from the row 1 that I multiplied, and then it will be my new row 2. I'm sorry for this. And then for this, I'm going to say row 3, that's the whole of this row 3, minus row 1, that's the row above. Alright, so let's see how it becomes this matrix under. Alright, so I have 2 here. If I multiply 2 by 2, it will be what? 4. Alright, so the 4 I've gotten up here minus this 4 down here, that's what gave me this 0 here. Are we there? Alright, so if I multiply 2 to this 3, I have 6, and then the 6 I got minus 4, it gave me 2. If I multiply 2 with this minus 1, I have minus 2, and then I subtract row 3, that's this. So minus 1 minus minus 3, you know, the negative will become positive now. So that's why I got 1. If I multiply this 5 by 2, and then it gives me 10, then the 10 I got minus this 3, I got 7 here. Okay, so because I want to get my new row 2, so I have gotten a fresh new row 2 which is different from this, but my row 1 is still the same. Alright, coming to row 3, because I'm trying to eliminate this, and this. So you see, already I've eliminated this to be 0. I'm going to eliminate this now. Row 3 minus row 1 to give me my new row 3. Alright, row 3 minus row 1. So 2 minus 2 is what? 0 here. Minus 3 minus 3. Since you are subtracting, so I got minus 6. Then 2 minus minus 1, it becomes positive now. Then I have 3. 2 here minus 5 I got minus 3. Alright, so I hope we all understand. So the next step, I've already succeeded in eliminating this. So the next thing I'm going to do is to try to eliminate this 6, this minus negative 6. Alright, for me to eliminate the negative 6, I need to multiply my row 2 by 3, then I will add row 3 to it so that this 6 will be 0 to give me my new row 3. Alright, so as you can see here, comparing the two equations, this and this, the same row you have in row 1 is the same thing here, the same row you have in row 2 is the same thing here, but the row 3 will differ because you are getting a new row 3. So let's see how it will be. 3 times 0 is 0. 0 plus 0, 3 times this 0 is 0. 0 plus 0, it gives me this 0 here. Okay, so the next step is 3 times 2 is 6. 6 plus minus 6, it gives me this 0. So I've succeeded in eliminating this also, but I'm not stopping here. I will finish for the whole row. 3 times 3 times 1, is 3. 3 plus 3, that's what I got, the 6 here. So 3 times 7 is 21, and 21 plus minus 3 is 18. Alright guys, so as you can see, based on Gauss elimination, I have succeeded in eliminating the lower triangular matrix. Some may decide, as students may decide, to just use their backward substitution to get their final answer here, while others may decide to make the whole equation a normal Gauss elimination. That's by making your leading diagonals to be 1s. That's here to be 1, here to be 1, here to be 1. Alright, but let's see the normal, and then we'll see by making it the leading diagonals to be 1 and see if the answer will be the same. Alright, so I take my matrix, my coefficient matrix, and I will turn it into a system of linear equation again. So the 2 here, as you all know from the question above, you already have unknowns, as you can see, x, y, and z. So now we are going to continue with the solution, and as you know, our unknowns are what we are looking for. Alright, so let's see. The 2 I have here, it becomes 2x plus 3y, and this is minus z, equal to this 0. I forget about it because 0 cannot add anything and cannot change. Alright, so I have this, and here I eliminate. So this is how my equation will be now. So I will use my backward substitution to get the value of x, y, and z, but I will start from z. That's why we call it backward substitution. We start from z, then coming to y, then to x. Alright, as you can see the solutions here, I've taken this here, so I will make z subject of the formula. I've gotten my value of z to be equal to 3. So I will now use the value of z as 3 to find the value of y in equation 2. Alright, so I've taken equation 2 as it is here. I've taken it here. So my 2y is here, my z. Already I've known the value of z to be 3. I put my 3, and then the 7 is here. Alright, so I'll collect like terms, this, and as you know, your y will be 2. Coming to x now, I take my equation 1 here, and that's the same thing I have here. So I'll put the value of y and z into this equation to get the value of x. So I have 2x plus 3y, and this, putting my 2x is here, the value of my y is 2, I've put the 2, and then that of z is 3, equal to this. If you subtract this, you have 3, you collect like terms, you get the value of your x to be 1. Alright, so automatically we know the value of our x, y, and z. Okay, Our value of x is 1, our value of y is 2, and our value of z is 3, as we see from here, here, and here. Alright, but when we are talking of Gauss elimination, in order to make our equation valid, we need to make, that's why I wrote here, now making the leading diagonal to be ones. These are the leading diagonal. This is the leading diagonal of this row, this one, and this. So we need to make the whole of these leading diagonals to be 1. That is where we have our automated and a very accepted Gauss elimination solution. So that's why I've also written it here. We need the solution to be in this form. Alright, let's see how it will be. So as I was saying, this is how it's going to be. This is the same equation. I didn't change anything, please. This is the same thing that I used here, that I tell you that we're going to change this leading diagonals to be 1. Alright, so now this is our matrix. So to make this leading diagonal to be 1, I need to divide the whole of the row by 2, so that 2 divided by 2 will be 1, this also by 2, and here by 6. This is what this is saying. That's 1 over 2 row 1. Divide the whole of row 1 by 2, 1 over 2 row 2, divide the whole of row 2 by 2, and 1 over 6 row 3 to divide the whole of row 3 by 6. So this is what I did here. The whole of the row, 2 by 2, 3 by 2, minus 1 by 2, 5 by 2. Here also 0 by 2, 2 by 2, 1 by 2, as it is here. Alright, so the next step is the one that it would be properly divided, you divide it, and the other ones we can leave it and see how it's going to be. So I'll write what the next step will be. So this is what we are going to have. If you divide 2 by 2, you have 1, but this one is there, this one is there, this one is there. 0 divided by 2 is 0, so we have our 0 here. 2 divided by 2 is 1, and your half here is here. Your 7 over 2 is here. Your 6 divided by 0 is 0, 6 divided by 0 is 0, 6 divided by 6 is 1, and then 18 divided by 6 is 3. So now we're going to use our backward substitution as usual, as we did in the former, and see if our equation will give us the same as that of x and y, x, y, z that we got in the first equation. So let's see. So guys, I'm writing all this because of time. The whole thing should not be too lengthy. Alright, so I turn this into my normal system of linear equation as in our matrix. Alright, then using backward substitution, as we know already, our z is equal to 3. That's why I wrote 3 from equation 3. Then from equation 2, I picked this equation 2 and I wrote it here, and then now I'll put the value of z3 into the equation. So you go through it, y plus 1 over 2z. Okay, this you go through it, 3 times 1 is 3, then over 2 here, and this one is here. Here you collect like terms, this one will come here and it will be negative, and you subtract. Since the denominators are the same, you just subtract the numerators. You have 4 over 2. So if you divide 4 by 2 is 2. So coming back to equation 1, so I just picked this equation 1 here. The equation 1 I have here, as you can see it clearly, so was the equation I now put here. So I'll put the value of y 2 and the value of my z 3 into this equation. Alright, let's see. Here is your x, and then you have this as the equation. Your value of y is 2, your value of z is 3. So 3 times 2 here is 6 over your 2 here. Negative is here. 3 times 1 is 3, 2 here also. And then if you subtract 6 over 2 and 3 over 2, you have 3 over 2. Okay, so now collecting like terms here, this will cross to the other side, and you subtract here, you have 2 over 2, and then your value, the value of your x is 1. Therefore the value of your x is 1, the value of your y is 2, the value of your z is 3. If you remember the other one that we did, also we got the same values. So any way you follow, your answer will all be the same. So it doesn't matter the procedure you used, you can use any. Please, if you have any question concerning the Gauss elimination, you can comment on the video and then you ask your question and I will get back to you. Thanks for listening, and please don't forget to subscribe to the channel for more of answers to your assignment, and thank you very much.